going to talk about the MROS Vaisala version. Not to be remiss if I didn't mention this. This is a tidbit and a half. Jesse is a Navy veteran, an AG, aerographer's mate, who was helping back up rescue operations during the Iran hostage situation back in 1980. So definitely thank you for your service on that. That had to have been an experience and a half, but feel free to go ahead and take off there, sir.
Okay, can you hear me okay?
Yeah, you're coming through loud and clear. I like the background
okay.
too.
Okay, let me go ahead and share this. Okay, can you see that?
Yes.
Okay, let me go ahead and hide this. And I'm just going to give a, this is going to be pretty short, but I'm going to give just a brief bio of myself. I was in the Navy from 1977 to 1983 as an aerographer's mate, and spent a year and a half on an aircraft carrier, and my first upper air release was on the back of that carrier. That was back in 1979. Let's see, I went to forecasting school, observer school at Chanute Air Force Base. After I got out of the Navy, I worked for a business from 1983 to 1990 that did contract work, sending up weather balloons for the National Weather Service out in California at San Diego, and then Oakland, where I managed the upper air office. And I think Ralph Estelle was there for about 6 months with me. I did join the National Weather Service in 1990 at San Francisco, and then went down to San Diego in 1992, and then to Dodge City in 1994. And I've been here ever since. I did become the OPAL back in 2007, or somewhere right around then. This is the overview for the MROS Vaisala system. Let's see, this is, let me move this here. Yeah, this is the Radioson RS-41. It's lighter than the LMS-6 SON, about 35% of what the LMS-6 weighs. This weighs 80 grams. It consists of a temperature and a humidity sensor. The pressure, the geopotential height, and the wind is calculated by GPS. And the workstation itself is known as the M141 and consists of a PC, monitor, the SPS, and a ground check device. This is the telemetry antenna RB31 that was supposed to be located on the roof of our WFO, but headquarters had safety concerns with that, and it ended up being in the upper air dome. And got a photo of it in the dome itself. There it is. The SPS is located below the RB31 antenna. That's inside an enclosure. And there's the photo for that, and the SPS is right there. I think the ETs would rather have that stay in there, so I'm not sure the antenna itself. So I'm not sure if that's actually going to stay in there. There's talk of building a tower for that antenna to mount on. So I'm not sure if that's going to happen or not. There is a GPS antenna for the MROS system, but we are not using that at this time. We are using the old GPS antenna from the RRS system. This is the ground check device. You just set the Radioson on that, and then it gets activated with the software. This is the screen for baselining. The right-hand side shows the frequency. That can be changed manually if you need to do that. And let's see, this next screen here. Let me see if I can zoom in on that just a little bit. Yeah, this is your where you would enter your surface data and your metadata. Let's see, yeah, the metadata is on the right-hand side, and the surface data is on the left-hand side. After you've released the balloon in the sun, you will look at your raw data here and check out your ascension rate to check and see what time your release was. You can compare it to the time that the system used and change it if you need to. You can also change your surface observation if you need to. Now, this is the main screen you'll be looking at when you're doing your flight. Other screen you'll mostly be looking at too is your skew-T plot. What is this being displayed here is the EDT values. I think that stands for editable values. This part here, you can make any edits, such as a super off the surface. And if you're getting a wet bulb effect aloft, you'll click on the edit button down here at the bottom, and then you can make your edits. I'm going to go through the process of the install and the training. The installers and the trainers arrived at the WFO the week of November 29th. Everything was installed by that afternoon, and the first test flight was around 20Z. There was an issue between the upper air building and the WFO with communication, but that did get resolved pretty quick. And we were able to get our first operational flight that evening at 0Z. We did a total of 4 flights each day from Tuesday through Friday. That it did include the 12Z and the 0Z flights. There was a mid-morning flight and also a mid-afternoon flight. There was a requirement for at least 3 certified observers that had gone through the MROS training on the CLC site. The training that week for each observer consisted of 3 flights. The first one was an observed flight. The second was a flight you did with the help from the trainers, and the third one you did on your own with the trainers observing. There was no limit to how many people can observe their first flight at the same time. We were able to get a total of 6 observers complete their training that week. The trainers stayed through the 0Z flight that Friday evening. Now let's see here. Yep. I'm going to go through some of the issues that we've had with the system since the install. And I do want to say we have had no missed flights. Here are some of the items that need to be fixed other than the buffer messages. The freezing level, the mandatory, and the significant and above messages are transmitted manually. The MW41 software does not populate the RSOS data for your observation. That has to be entered manually. There is no backup to transmit the messages. The RSOS display does not close when you click on the X in the upper right. If you expand that display, and the X button gets hidden just off the screen, so you have to be sure to pull that back to the left and then hit the X button to close it. I did accidentally close the MW41 software the first time I tried that, if you don't pull that back to the left. But if you do happen to close the software, you can log back into it, and then you'll be right back where you left off with the sounding. Let's see, another thing. The freezing level message will not generate if you enter 0 to 0.3 degrees Celsius for surface temperature. You need to enter minus 0.1 degrees Celsius for the surface temperature. Another thing that one of the observers discovered, if you click on the maximum button for any table or plots and leave it like that until the end of the flight, you will not be able to close your flight. The close sounding button will be missing. You'll have to click back on the maximum button to get that close sounding button again. Now, let's see. Overall, I'm very satisfied with the Vaisala system. I do like that there is no battery to connect, and you can also observe what is going on with the baseline. Let's see here. Talk about a box of radiosondes comes with 40 radiosondes, and there are some serial numbers that are skipped. The serial numbers on the wrapping for the sondes, it is time consuming to put those in order in the cabinet. There are also a couple smaller boxes for the lifting posts that are inside the box of sondes. I did yesterday restock the cabinet there for us, and it did take me about 40 to 45 minutes to restock that cabinet because I like to get those serial numbers in order. The 500-gram lifting platform. Oh, that's the lifting post right there. Once you snap that onto the radiosonde, it should push the boom to a 45-degree angle. Here we go, the 500-gram lifting platform. We do have one 100-gram weight on it right now, so we're testing that out. And let's see. So we do have a bucket that we use during windy conditions. There is a plastic container attached to the bucket by Velcro. There's a hole in the bottom of the container for the antenna to go through with a slit along the side. We can also use a shepherd slick on non-windy days also. Let's see, I got another photo here. Yeah, this is a photo of the RRS GPS antenna, which is the one we are still using. And the last thing I want to go over is just some statistics. This is for December and the early part of January using two 100-gram weights on the lift platform. We did have a total of 60 flights for December. That was a very warm December. I think we had a record for average high temperature that month. Average bursting height just above 33,000 meters and 7.5 millibars. Average ascension rate was a little high. Surface determination, 332 meters per minute. We did have a cold spell at the beginning of January that first week, so 14 flights. Average bursting height was a little bit lower, almost 32,000 feet, and average bursting height was 6.8 millibars. Actually 12.8 millibars. We did have one flight that did hit 90, that only made it to 90, so that was included in that. If you take that away, the average is 6.8. But the ascension rates were higher, 339 meters per minute. And then we did remove one 100-gram weight on it, and we've done a total of 22 flights since we did that. Average bursting height just above 33,000 meters, 7.4 millibars. And ascension rates have done better, 323.6 meters per minute. So we may try to remove that last weight on there and see what that does. That's pretty much all I got for now. So if you've got any questions.
Oh,